Good afternoon, children. Yesterday, as we were discussing separation of mixtures, how we can separate the components of mixture. We have discussed a few methods. Some are very simple, that is filtration, sieving, hand picking, all these are very simple methods, or you can say they are just physical methods. Just by hand picking you can take out the stones from the wheat, but some require some special technique, and the methods which we have discussed yesterday, they are, the first one was evaporation, next we discussed sublimation, then we have discussed separation by separating funnel. Separating funnel. Here we have taken immiscible liquids. Immiscible liquids means liquids which do not mix with each other. That is water. Example I gave you of water and oil. We had taken in a funnel, and that funnel, it has a stopcock. What is the principle of that? That the two components of mixture, that is water and oil, they have different density. One is lighter, one is heavier. That one which is heavier, which will settle at the bottom, and the one which is lighter, it will settle on the upper surface, right. So, what is done? This mixture, it is filled in the separating funnel, stopcock is opened, water being heavier, it will settle down, oil being lighter, it will remain up. So, till all the water comes down from that stopcock, till that time the stopcock we keep open, and after that we close. So, here we have in the beaker water, and whatever is left in the funnel, that is oil, right. So, principle is difference in the density. And what is practical application? Practical application is separating oil from water. Then one more practical application in the industries is that when iron is extracted from its ore, that is in metallurgy, from the ore, the iron ore is taken out, and that iron, it is, though it has iron, but there are many other things present in that iron. So, that iron is being melted, and this process is called as metallurgy, and iron is separated from all the impurities are separated from iron, and at last we get two layers. One layer is of molten iron. Here, this is molten iron, and the other, it is slag. It is called as slag, that is what? Calcium silicate. All the impurities, calcium silicate, right. So, you have two different layers, one is molten iron and the other is calcium silicate. These are all the impurities, and this is heavier, molten iron, and this is lighter. So, what is being done is that it is taken out from here, molten iron is taken out, and slag, that is impurity, it is left in the container, right. So, in this way, this is the practical application of this separating funnel. Then next comes sublimation. In the last chapter, children, we have already done sublimation. What is sublimation? We have seen that usually what happens when a solid is heated, it changes into liquid and then it changes into gases, right. But some of the substances, they directly changes from solid to vapor or gaseous state. This process is called as sublimation, and the substances which undergo this process, they are called as sublimates or sublimes, right. So, if you have a mixture of ammonium chloride, that is NH4Cl, and you can say salt or any other thing, right. So, this ammonium chloride, it undergoes sublimation. So, what is being done here, that is, this is a china dish or watch glass, you can say. This is a china dish. It is made up of glass and its shape is like this, curved, right. So, in this china dish, what is kept? Mixture of ammonium chloride, mixture of ammonium chloride and salt, and then here from here it is being heated, that is, you can say, heated by a flame, right. And above this is kept a funnel. Above this is kept a funnel, and in the funnel there is kept a cotton plug. This is funnel, and here there is a cotton plug. This is a piece of cotton, right. So, what happens when this mixture is heated? Ammonium chloride, it is a sublimate substance, it will sublime, and here the vapors will rise. These are vapors, and these vapors, they will get condensed over here and they will form solid ammonium chloride. And what is left here in the china dish? That will be salt, right. Here first we have taken mixture of ammonium chloride and salt. It is taken in a china dish. This china dish, it is covered with funnel is inverted over it. Here in this part of funnel there is placed a cotton plug so that the vapors should not go out. Now it is heated. Ammonium chloride, because it is a sublimate substance, so what will happen? Directly it will change from solid to gaseous state, and vapors of ammonium chloride will rise here, and you will get deposition of ammonium chloride here, right. And what will be left in the this thing, china dish, or you can say that whatever is left, that is what? That is salt. So, this is another method of separation of the components of mixture. And what is the principle, what is the basis on which we are able to separate this? That is, one of the component, it is sublimate. Sublimate means it will get volatilized at room temperature. It will form vapors at room temperature. Next method, it is chromatography. Next method of separation of mixture, of components of mixture, it is chromatography. Chroma, it is a Greek word and you can write here chroma means color and graphy means writing. So, here the method is chromatography, and what do we do in the dyes? There are present different colors, or you can say pigments. So, different colors or different colored pigment, how they are separated from a dye, this method by the method that is called as chromatography. Chroma means color and graphy means writing. So, what is done here? A strip of filter paper is taken. This is the strip of filter paper. Filter paper strip, right? On that strip is drawn a line with pencil. This is the line drawn with pencil, right? And on that line, what is done? A drop of ink is poured. Ink is what? Ink is colored either red or blue. It has dye and it has different pigments, right? So, ink is taken either red ink or blue ink, and we have to separate the different component of this ink. So, first a strip of filter paper is taken, a line with pencil is drawn on it, on that line a drop of ink is poured, right. Now, this strip of paper, it is taken in a glass jar. This is the glass jar, and on the top of this glass jar there is a glass rod. A glass rod is kept here, and this strip of paper, with the help of pins, it is attached to this glass rod, and in this glass rod, in this glass beaker, you can say beaker, there is what? Water. With the help of clips, this paper, this filter paper, it is here, this is the line drawn with pencil, and this is the drop of ink. Now, what is the principle? On what basis or what is the theory of this process? How you can separate different components of dye by the process of chromatography, children? What is the theory? What is the principle? That the different pigment of the dye, they have different solubilities in the same solvent. In the same solvent means this is water is the solvent here, and this ink, drop of ink, it has different pigment, and this it has different colors, right. So, this different color, it can be separated on the basis that some will dissolve less and some will dissolve more. So, what happens, as soon as you keep this or you put this strip of filter paper in water, what will happen, that different pigments which have different kind of solubilities, they will start rising up. They will start rising up. Some, you can say, they have reached up to this point. Some they have reached up to this point. Then some they have reached up to this point. Right? It will all depend upon their solubility in water. So, in this way we can separate different pigments of dye, right. So, again let us revise this chromatography. Chromatography is one of the method of separation of the components of mixture. Chroma means color and graphy means writing. Here dyes, they have different colors, different pigments they have got. And what is the principle, what is the basis? That different colors or different pigments, they have different solubilities in the same solvent. Same solvent is water here. Water is the solvent and some will dissolve more, some will dissolve less. Those which will dissolve more, they will rise to the height, and those which will dissolve less, they will remain at the bottom. In the same, this way you can say at different position, at different places, you will see different colors or dyes, different pigment of the dyes. So, here you take a strip of paper, on that strip of paper you draw a line with pencil and then you put a drop of ink on it. Now, you take a glass rod and with the help of pins you attach this filter paper or strip of filter paper on the glass rod. This glass rod you will put in a glass beaker. This is a beaker and in that beaker there is some water. And you will see that this up to this place means where till where there is a drop of ink, till that point it is dipped in the water. So, different dyes or different color pigments of the dye which are present in the ink, they will rise according to their solubility in same solvent, that is water. In this way you can separate. So, here, and what is the practical application? Practical application. Practical application to detect the presence of drug in blood. If in the blood there is present drug, then it can be detected by the process of chromatography. In the same way, a strip of paper taken and on that strip of paper a drop of blood is put and then it is the same process we do and you see that how does it rises, that drug rises up and that drug is tested and then it is found that the blood do have any drug or not. And also you can separate the pigments which are present in the natural dyes. In the, you see leaves. Leaves are green in color. Then flowers, usually they are red in color. There may be some yellow also, purple also, right. So, this has green pigment and this has red pigment. And because of that green pigment only, leaves are green in color. Because of this red pigment only, flowers they are red in color. So, these pigments or dyes, they are usually separated from the natural, you can say, leaves and flowers by the process of chromatography. So, this is all about chromatography. Then next method of separation of component, that is distillation. Distillation. Here, suppose we have done separation by separating funnel. In that case, the liquids, they were immiscible. Immiscible means they were not getting mixed up with one another. Now, if suppose you have a mixture of two liquids such that they get mixed up with each other, then how you will separate? Then you will find it difficult to separate, right? So, here in this, what happens? Those liquids which are miscible. Miscible means they get mixed up with each other. They are separated by the process of distillation. For example, if you have a mixture of water and acetone. Acetone is an organic solvent. It is also liquid. Water, you all know that it is liquid. Its boiling point is 100 degree and its boiling point is 56, right? Now what happens? Both are liquid and both get mixed up, and if I have to separate them, then what I will do? I will try to do that by the process of distillation. Here in this process of distillation, what is being done is